Hello class. What I'd like to do today is kind of go over this particular formula here, and I'll give you an example. And I've got some videos, but I just wanted to clear the air on some of the videos because they're not real clear, so I want to just clear and make some clarifications on this. So what we're going to do in our homework, and what we're going to cover in part of chapter 9, and I'll give you another homework over in ANOVA, but let's cover this one first. This one right here is going to be the sum. We're going to be looking at the mean of groups. We're going to have two groups here, so we got group 1 and we got group 2. So I've got some data here that I put on the board, and it's going to be class 1 and class 2, and let's say that these are statistics classes, and I've gotten the data from the different statistics classes that I've taught, and I've got a independent variable that is going to be given to class 2. So the independent variable is going to be video supplementation. So class 1 did not get video supplementation. All they got was lectures and homework and textbook and PowerPoints. Class 2 received all of that, plus they got video instruction. So they were able to go online, watch the videos. So what I'm saying, I'm going to hypothesize something. So my hypothesis is going to be that my null hypothesis, meaning nothing, is going to be mu1 is equal to mu2. My alternative hypothesis is going to state that mu1 is less than mu2. Now how I'm going to find that is I have to have what's called a critical region or a critical value. And my t-test or my t-distribution is going to look similar to a z-distribution, having a mean of 0, standard deviations of 1, 2, 3, and -1, -2, and -3. So what I'm saying is that I have two distributions, and these two distributions are going to be significantly different from each other with, let's say that this is group 1, group 1 over here, which has a mean of, I got to figure out the mean on this, and I'll show you how to do that. I believe the mean is 74 on group 1, and I'm saying that I've got another group over here, and it's going to have a mean, and I'm saying it's going to be, this mean is going to be higher because I said that this mean here is less than this mean. So if I've got another distribution of scores with a mean, it's going to look like this. And let's just say, I can't remember what the mean is on the second group. We can figure that out though. So I have something called degrees of freedom that I need to know. So let's go ahead and put degrees of freedom. So I have how many degrees of freedom? Well, I need to figure that out. I have n equals 10, or that's n1, and n2 equals 10. So the rule of thumb here is n1 plus n2 minus 2. So I add n1 and n2 up, I get 20 minus 2, I have 18 degrees of freedom. So what I have to do with the 18 degrees of freedom is I have to come to a chart, and the chart that I'm going to use is a t chart. This one's a z chart, so I got to find my t distribution. So right there it says t distribution. Well, I got to look at another thing here. I got to look at alpha. So my alpha level is going to be equal to 0.05. So that means that I've got 5% of the time I could make a type 1 error. So I'm going to be 95% confident that my results are going to be true. With 5% of the time, I could be wrong. So if I find that I have significant differences, there's a 5% chance that that's not true. That's what that means. It is a one-tailed test because on my alternative hypothesis, I hypothesize that the mean of group 1 is going to be less than the mean of group 2. So now I have my information to find my critical value. So I have a one-tailed test. I'm using an alpha level. That's that little alpha, one tail, and I'll come to a 0.05, and I've got 18 degrees of freedom. So I'll follow this thing down until I find 18 degrees of freedom, and I've got 1.734. So 1.734 is my critical region, or my critical value, 1.734 standard deviations from the mean. And since I'm saying that this is a less than, so this 1 is going to be less than 2, so I'm saying that this mean is going to be less than 2, so my critical region is going to be negative 1.734 standard deviations from the mean. So that means that 74 needs to fall in this region of 5%. That's what this is, 5%. So the rest of this distribution over here is going to have 95% of the total distribution in this area. So let's go ahead and get started, and I will go ahead and explain how we can test this hypothesis using this particular formula. So I will try to clear this up in the next video.